Okay, so this is an example of the type of question that can come up on exams, just to take a look at it. So Maddie has found the attendance chart for students in school for the previous year. This is the number of days present they were in school, and this is the number of students. So for instance, there was just a few students who were only there between 21 and 40 days. So we'd read off the top of these bars to figure out what it is, and we're trying to take a look here to estimate the proportion. Remember, that's similar to probability. You want to think part out of total, who attended for less than 100 days. So 100 days is here. I'm looking for how many students are in that group compared to the total. So first thing I'm going to do is figure out how many are less than 100, and I might just approximate these numbers. You can see there's just a faint little line there, so I might assume that's one student. This is kind of halfway between 0 and 50, so I might say 25. This one here I might say something like 20, a little bit less than half. And this one here maybe, not quite halfway between 100 and 50, so maybe 70. So if I add those up, 1 plus 25 plus 20 plus 70, I get 116 students. And I need to know out of how many total. Well, unfortunately in this problem they weren't nice enough to give us the total, so we do actually have to calculate that. So we need to figure out how many in each of these groups as well. So I might, not sure, approximate here somewhere just over 250, maybe 260. For this one here, just below 350, maybe 345. For this one here, just about at 200. And for this one here, roughly one student. And again, these are approximates. You don't have to be exact on this. They would look at kind of a range of acceptable answers. So this is the part, the ones that are less than 100 days, and I need to know my total, which is that 116, plus the other ones that I added up here, or measured up here. So 260 plus 345 plus 200 plus 1 gives me a total of 922 students. So the proportion, the part over total, is going to be 116 over 922, and that equals 0.1258. So that's your proportion less than 100 days. Okay? So again, just reading off the y-scale to figure out what you need there and get your part and your total. Next question, is Maddie justified in thinking that students in this attendance chart are normally distributed? So we would want to talk here about whether or not we think this is okay to be a normally distributed graph. So we need to kind of look carefully at this graph and think about those things that we know we're looking for. Symmetry, the bell shape, if the mean is centered and not. Anything about the shape if it's skewed one way or the other. So if I look at this graph, I notice that it approximately has a bell shape. It just got a long tail over here. But if we ignored that tail, you can see it's got pretty good symmetry. It's just a long tail that pulls off there. Another thing to notice is that most of the data points are kind of near the mean, and both the tails on both ends kind of drop away towards 0. So if I was going to talk about this, is Maddie justified in thinking students are normally distributed here in this table? I might say it is not perfectly normal, but fairly close. So she is justified. My reasons for this: the graph is sort of symmetrical or bell-shaped. There is a long tail to the left, so the graph is skewed left. Most of the values are near the center, and the approximate mean is mean again would be slightly near the middle where the peak is, and if you have extreme values that go off one way or the other, you skew it slightly towards that. So I'd say it's pretty close to maybe 125 or something. So that's the tallest peak, and it's not going to be right smack in the middle because of that tail, so I'll move it, think about it as being about 125 days. What else? Both tails, the extreme values reduce towards 0. What else can we think about with this one? Thinking about the context, one thing that's true about normal is that the tails should be able to go on forever. So one thing that's slightly weird about this is that we do have limits. You cannot have more than 180 days at school, and you cannot have less than 0 days at school. So you might say it is not, maybe not, it is limited by a max value of 180 days and min of 0 days. So that kind of gives us some reasons why, some justifications why, that it is fairly bell-shaped. There is a long tail to the left, so the graph is skewed left, but most of the values are near the center, and the approximate mean would be 125 days. And both the tails, the extreme values reduce towards 0. So those are all good things about it being normal. And so it's, it's not great, but it's pretty good.